All right, let's look at circles and what circles look like in both the polar setting and the Cartesian setting. So here I have a polar equation, and hopefully you recall from last week that whenever we have a simple like cosine or sine function, that will make a circle within the polar mode. And so how do we draw that? So let's kind of take a quick little look at Desmos here to help us with this. Let me kind of slide things back. I was playing with this earlier. Let's kind of think about the fundamental cosine equation. Set that back to 0. Okay, so here's the graph of the equation. Turn that off for a second. Of r equals cosine theta. It has a diameter of 1 unit. In fact, I created a little piece on Desmos here to kind of show that diameter, okay, of 1 unit, and it's kind of resting or straddling the x-axis. If it had been a sine function, we would have seen a circle probably up here. But let's move on. So in our problem, let's see, the a that was 5, and that has a dilating effect. So it kind of dilates the circle, basically stretches the diameter out to be 5 units. And then we have to be a little careful on here. Let me get that back to 0. Is theta minus b. Well, in our problem, I think it was theta plus 105. And so we have to be thinking, oh, that means like theta minus negative 105. Remember, transformations inside, go the opposite way. So we've got theta plus 105. So then I want to set my b to like a negative 105. So theta plus 105 means I'm going to rotate negative 105 degrees. 5. Oh, can't seem to get it on 5. Well, close enough for right now. So we're going to have a circle that's kind of down in this area right here. Let's take one more crack at it here. There we go. Well, I had it. Well, my touch is off. Oh, now we're good. So there's our circle. All right, well, now we would like to do this without relying on Desmos if we can. So let's kind of go through the steps in our head or on paper here. So first of all, the diameter goes out 5 units. 1, 2, 3, 4, 5. And then we're going to rotate a negative 105 degrees. 15, 30, 45, 60, 75, 90, 105 right there. And so the diameter of our circle is right here. From the pole right to that spot. And then we just try to draw kind of a nice round shape. Circular-like shape. And this, again, I suggest you do these in pencil so you can kind of make adjustments as you go along. Again, remember, that's just a sketch. Okay? And when you have a little more practice, you'll get better at kind of sketching the circle. But something kind of like that is what you're going to have. Okay, and so now the next thing is, all right, well, how do we convert this to a Cartesian form? Well, there's a couple ways to do this. Before, when we were working with lines, we talked about kind of a geometric or visual way and then a purely algebraic way. So let's look at a geometric way to do this. The diameter is really a big key right here because you're between these 2 points right here and here, and you need to find the center of the circle. And as you can probably tell, well, if this is at 0 and then this is 1, 2, 3, 4, 5 units going out, that halfway would be the center. There's the center position, okay, 2.5 units away. But we need the Cartesian position. We need to know the x and the y, okay, the x and the y that are going to kind of put us at that center point. So that suggests the idea of a triangle, which let me go ahead and draw that triangle right over here. It's just a right triangle. As I've been mentioning a few times already, right triangles are a really, really big piece of a lot of things in math analysis. So let's think about what we have here. We know that this is 2.5 units. We don't know what the x and y are, so for now I'm just going to call them x and y. And I need to get an angle inside this triangle. Well, again, you do a little bit of thinking and you say, well, it took 105 degrees to get here. So that means this little angle right in here, if this is 105 right here, this has to be the supplement. That has to be 75 degrees. So we could take, say, 75 degrees. And so now we can start to do a little bit of trigonometry on this and say, well, okay, the cosine of 75 is x over 2.5. So cosine 75 degrees equals x over 2.5. And then we can use our calculator to figure that out. Again, make sure we're in the right mode first of all. Okay, degree mode. Let's clear that. So we'll go cosine. In fact, I'm going to go 2.5 times cosine 75. 2.5 times cos 75. And that tells me it's about a 0.647. 0.647. So 0.647 for x. And then for the y, we could say, well, the sine of 75 equals y over 2.5. And we'll better focus on that. Okay, so let's see, then that would be 2.5 times sine 75. So 2.5 sine 75, about 2.415. 2.415 equals y. And so now, again, using our picture, we could say, okay, well, each of these is negative. The x is negative and the y is negative. So that would be the position of our center point. So the center is located at negative 0.647, negative 2.415 in Cartesian. And now the other part is the radius. Well, the radius, we know the radius is half the diameter. If the diameter was 5, the radius is 2.5. So we have a radius of about 2.5. So meaning we could start to design the equation for this circle in a Cartesian sense. We could say, all right, well, x plus 0.647 squared plus, and then y plus 2.415 squared, and I've run out of room here, so I'll just put it on the other side. I'll just put it right down here, equals 2.5 squared. 2.5 squared. 2.5 squared. About 6.25. So 6.25. And so there we have an equation, okay, for the circle, but in a Cartesian sense. So now we could go on to Desmos and we could kind of type that in and check to see how well it matches the graph we had at the outset. So we'll kind of switch back over to Desmos here and make this a little smaller. Might be a little better there. Okay. And so I'm going to go into I'm just going to go ahead and start typing in the equation. X, let's see, plus 0.647 quantity, let's see, squared, plus, and then y plus, sorry, 2.415 quantity squared equals 6.25. And there it is. It sits right on top. I'm going to shut that off. And so there it was originally in polar, and then in Cartesian, it's sitting right on top. So I feel like I have a pretty good answer there in terms of the Cartesian method. So that's kind of the sort of the geometric way, the visual way of kind of working this out, turning it from polar into Cartesian. Now there is a purely algebraic way. And notice you've got cosine of two angles that are being added together. So we could use the sum and difference formulas. And so now let's give that a go right down here. Slide this down a bit, and hopefully we'll see if we can get it to match this. So we have, let's see, the original was 5. Move that over a little bit. 5 cosine theta plus 105. And that was equal to r. So we've got r equal to. Okay, and we have to get rid of the r, and we have to get rid of the theta. So first thing is we'll kind of work on this expression right here. So cosine of a sum, that would be cosine of the first, cosine of the second, minus sine of the first and sine of the second. And out in front of all this, of course, is the 5. And I might as well put the r equal to there. I just don't forget it. Okay, so now the next step is let's work out cosine 105 and sine 105 and see what we get from that. So let me go ahead and do cosine of 105 and sine 105. And so I'll now take those decimals, I'll round them off a bit, and we'll put them right in there. So, okay, so cosine of 105 was about negative 0.25, I'll go 2588. And sine of 105 is about 0.965. Now the next step is we'll go ahead and we will distribute 5. And so we'll bring 5 in here and we'll bring 5 in over there. So we're going to distribute 5 here and we'll distribute 5 right here. And so what are we now looking at when we do that? Well, we have, so 5 times 2588. So we have 5 times negative 0.2588 equals that. And then I'll do 5 times the other number as well. 5 times 0.9659. I'm going to go ahead and record those values onto my paper. So 5 times negative 2588 is negative 1.294 cos, and then I'll have minus, the minus right here, 4.8295 sine theta. And then that's equal to r. And so at this point where you're kind of going, wow, what do we do? Again, we're trying to get rid of theta and r. And so again, it's that idea like, well, how do x, y, r, and theta all relate to each other? So you have to go back and just kind of recall, okay, let's think a bit about this. X and y are the sort of the horizontal and vertical coordinates, if you will, and then r and theta are right here. So among other things, cosine of theta is x over r, sine of theta is y over r. So if we said cosine of theta equals x over r, and then sine of theta, why, that would be y over r. So what I'm going to do is I'm going to replace the cosine theta and the sine theta with these expressions, and we'll kind of take a look at that. So I've got negative 1.294, and I'm going to replace that with x over r, and then minus 4.8295. And sine of r, I'm going to replace sine of r with y over r. So at this stage, you're going, okay, I've got theta out of the problem. Now I need to somehow get r out of the problem. And a nice little trick here, if you realize you're going, okay, let's multiply everything by r. Okay? That's going to create r squared, and it's going to get rid of the r's over here. So negative 1.294 x minus 4.8295 y. And so now, is there anything we can do with r squared? And you're going, yeah, well, r squared is the same as x squared plus y squared. So we'll then make that replacement. X squared plus y squared equal to negative 1.294 x minus 4.8295 y. So now everything is in Cartesian. The only trouble is you look at this and you kind of look at what we got from before, and they're not quite the same things. And you're going, well, how do we get this to look like the one above? And you might realize, okay, we have to go through and complete the square. So I will start this off for you, and then the rest I'll leave for you to kind of play with. So I would move everything onto one side. I would have my x squared plus 1.294x, then I would leave a little space, and then I'd have plus y squared plus 4.8295 y, and right now that's all equal to 0. And what remains for you to do is to try to figure out a number that will complete the square for the x's. It'll be kind of a messy decimal number, and then you'll need to add a number over here to complete the square for the y's, and it too will be kind of a messy decimal number. And of course, you'll need to add both of those things over here. But if you do that and you do it correctly, you'll find that this, okay, once you've kind of completed the square, should be pretty darn close to what you got right up here. So I'll leave that kind of challenge for you, is to kind of figure out what it's going to take to complete the square on these two pieces. Okay, so there's kind of a way of graphing in polar, and then a visual way to convert it to Cartesian right up here, and then a purely algebraic way to convert it into Cartesian. So on the next video, we'll take a look at going the other way, going from Cartesian back to polar.